Imagine waking up tomorrow and opening your kitchen. No refrigerator, no ice maker, no frozen food, no cold milk waiting for breakfast. Meat would spoil within days. Milk could become dangerous. And keeping food fresh would depend on ice, salt, cellars, and luck. Yet today, we simply open a door, set a temperature, and expect our food to stay fresh for days or even weeks. That simple box is one of the most important inventions in modern history. But the refrigerator wasn't invented by one person in one moment. Its story began centuries ago, with ice, chemicals, pressure, and a dangerous idea. What if humans could make cold instead of finding it? This is the story of how the refrigerator went from a scientific experiment to one of the most essential machines in the American home.
Long before electricity, humans already understood one simple fact: cold preserves food. Ancient civilizations used naturally occurring ice and snow to slow the decay of meat, fish, and other foods. In ancient Persia, people developed enormous underground structures called yakhchals. These structures were designed to store ice and keep food and water cold, even during hot summers. In Europe and North America, people later relied heavily on winter ice. But there was a problem. You couldn't make ice whenever you wanted. You had to find it, cut it, transport it, and store it. By the 18th and early 19th centuries, wealthy households often used specially insulated ice houses. And in America, something remarkable was about to happen. Ice itself would become a major industry.
In the early 1800s, New England businessman Frederic Tudor saw an opportunity. His idea sounded ridiculous at first: ship ice from cold New England to hot places around the world. In 1806, Tudor began sending harvested ice to warmer markets. The challenge was enormous. How do you ship frozen water hundreds or thousands of miles without losing it to heat? Tudor and others developed better insulation and storage methods. Eventually, American ice became a commercial product. Ice was shipped to cities across the United States and even overseas. People could now buy ice to preserve food. But there was still one major limitation. You needed nature to make the cold. The next breakthrough would change that forever.
Scientists had already discovered that certain chemicals could produce cooling effects when they evaporated. The key principle was simple. When a liquid evaporates, it absorbs heat from its surroundings, and that means evaporation can create cooling. In the early 1800s, inventors began asking a revolutionary question. Could this process be controlled inside a machine? One of the most important figures was an American physician and inventor named John Gorrie. Gorrie worked in Florida, where yellow fever was a serious problem. He believed cooling rooms could help patients, so he began experimenting with machines that could create artificial ice. In 1851, Gorrie received a U.S. patent for an ice-making machine. His machine compressed air, cooled it, and then allowed it to expand. The expansion produced a cooling effect. It wasn't yet the refrigerator we know today, but the principle was revolutionary. Cold could be manufactured.
Another major breakthrough came from an English-American inventor named Jacob Perkins. In 1834, Perkins patented a machine designed to produce ice using the vapour-compression principle. This was a critical moment in refrigeration history. Instead of depending on naturally occurring cold, the machine used a repeating cycle. A refrigerant evaporates and absorbs heat. Then the vapor is compressed. Compression raises its temperature. The heat is released, the refrigerant then cools and returns to liquid form. The cycle repeats. That basic concept became the foundation of modern refrigeration. But the technology still had a long way to go. The machines were expensive, they were large, and some early refrigerants were dangerous. The refrigerator existed, but it wasn't ready for the average family.
During the second half of the 19th century, refrigeration technology rapidly improved. Engineers began building larger and more reliable refrigeration systems. And the biggest early customers weren't homeowners, they were businesses. Breweries needed cold temperatures. Meatpacking companies needed to keep meat from spoiling. Railroads needed refrigerated cars to transport food across enormous distances. Ships needed refrigeration to carry meat and other perishable products overseas. This changed the food industry completely. Before refrigeration, food production was heavily limited by geography and seasons. But now, meat could travel farther. Fruit could be transported across the country. Fish could remain fresh longer, and food could be stored for extended periods. Refrigeration wasn't just creating cold, it was creating a new food system.
One of the most important figures in the development of modern refrigeration was German engineer Carl von Linde. In the 1870s, Linde developed highly efficient refrigeration systems based on vapor compression. His technology was particularly important for breweries and industrial applications. Linde's work helped make refrigeration more efficient and practical, and the technology spread rapidly. By the late 19th century, artificial refrigeration had become an important industrial technology. But there was still a huge gap between an industrial refrigeration system and a refrigerator sitting inside an ordinary American kitchen. At the beginning of the 20th century, refrigerators were still expensive and relatively uncommon in American homes. Many families continued using ice boxes. An icebox was exactly what its name suggested, a heavily insulated cabinet with a compartment for a large block of ice. The ice slowly melted and kept the food compartment cold. It worked, but someone had to deliver the ice, and someone had to remove the melted water. Then came the electric refrigerator. Manufacturers began developing smaller refrigeration systems designed specifically for homes. One of the major companies in this transformation was General Electric. In 1927, GE introduced the Monitor Top refrigerator. It became one of the first mass-produced refrigerators designed for widespread household use. The machine was still expensive compared with modern appliances, but it represented a turning point. The refrigerator was becoming a household appliance.
During the 1920s and 1930s, refrigeration technology continued improving. Manufacturers competed to make refrigerators smaller, quieter, safer, more efficient, and more affordable. But there was another problem. Early refrigeration systems sometimes used chemicals such as ammonia, sulfur dioxide, or methyl chloride. These substances could be toxic or dangerous if they leaked. The industry needed safer refrigerants. Then came a major breakthrough. In the 1930s, scientists at General Motors and DuPont helped develop Freon 12, a chlorofluorocarbon refrigerant. It was far less toxic and less flammable than many refrigerants used previously. This helped make domestic refrigeration much safer and more practical. The refrigerator was no longer simply a machine for wealthy households. It was becoming a normal part of American life.
World War II accelerated industrial manufacturing and technological development. After the war, American manufacturing capacity was enormous. Millions of households were ready to buy modern appliances. Refrigerators became increasingly affordable, and manufacturers began adding features that would completely transform the kitchen. Freezer compartments, automatic defrosting, adjustable shelves, temperature controls, and eventually, automatic ice makers. By the middle of the 20th century, the refrigerator had become one of the defining appliances of the American home. But how does the machine actually create cold? The surprising answer is, it doesn't really create cold. It removes heat. Inside the refrigerator is a closed refrigeration system. A refrigerant moves through a continuous cycle. First, the refrigerant enters the compressor. The compressor squeezes the refrigerant, increasing its pressure and temperature. The hot refrigerant then travels through the condenser coils. Here, heat is released into the surrounding room. The refrigerant becomes cooler. Next, it passes through an expansion device. Its pressure suddenly drops. The refrigerant becomes extremely cold. It then travels through the evaporator coils inside the refrigerator.
As the refrigerant evaporates, it absorbs heat from the food compartment. That heat is carried away. The cycle repeats again and again. So every time you open your refrigerator door, the machine is essentially taking heat from inside the box and dumping it into your kitchen.
The refrigerator was already revolutionary, but the freezer took food preservation even further. Freezing doesn't simply slow food spoilage, it allows many foods to be stored for months. That helped create the modern frozen food industry. Frozen vegetables, frozen meat, frozen dinners, ice cream, and countless other products became easier to store, transport, and sell. The refrigerator and freezer together transformed the way Americans purchased food. People no longer needed to buy fresh food every day. They could shop once and store food for much longer.
Today, refrigeration technology has entered another era. Modern refrigerators can use advanced insulation, efficient compressors, electronic temperature controls, sensors, and digital displays. Some even connect to the internet. Cameras can show what's inside, sensors can monitor temperature, and smart systems can remind owners when food may be running low. But underneath all that technology, the basic principle remains remarkably similar to the refrigeration machines developed nearly 2 centuries ago. Compress, condense, expand, evaporate, remove heat, repeat. The refrigerator is so common that we barely think about it. We open the door, take out the milk, grab some leftovers, get ice, and close it again. But that ordinary moment represents nearly 2 centuries of engineering. From ancient ice houses, to Frederic Tudor's ice trade, to John Gorrie's artificial ice machine, to Jacob Perkins' vapour-compression system, to Carl von Linde's industrial refrigeration, to the electric refrigerators that transformed American kitchens, the journey was long. The refrigerator didn't just change how we store food, it changed where food could be produced, how far it could travel, how long it could survive, and ultimately, how the modern world eats. The next time you open your refrigerator, remember, you're not just opening a box of cold food. You're opening the result of nearly 2 centuries of human ingenuity. And that's the history of the refrigerator.